As I said, there are a lot of cool things being tested out here, but one of the coolest is something called the Lunar Electric Rover, or the LER. Basically, it's a pressurized vehicle that's going to allow our current and future astronauts to travel much further than the Apollo astronauts ever did.
The rovers of the past were awesome, but before they came on the scene, Apollo astronauts were pretty much confined to a short distance around the landing craft. But after the rovers came around, man, did things change. For the first time, astronauts could really travel a good distance away from their landing craft and do some real exploring. But even as cool as the rovers were, they still had major limitations. They still had to carry all of their oxygen on their backs, and there wasn't much room for storage. And the astronauts had no protection from solar proton events, and on and on. With the new LER, NASA has really tried to address all of these major concerns. This new rover rocks. Astronauts will now be able to travel thousands of miles crisscrossing the moon in a protected, self-enclosed, pressurized environment.
So in this episode, we've talked a lot about the LER, but what we haven't talked about are the human factors that go along with it. So for 2 weeks straight, 14 days, we've had one astronaut living on this rover. And I got a chance to talk with him before he cracks the hatch. Let's go talk with astronaut Mike Gernhardt. Come on. How are you, sir? This is Johnny Alonso from NASA 360.
Johnny, how you doing?
Not bad. I'm sure you're counting down the minutes.
Oh, we got about 60 of those to go, so it's going to be bittersweet getting out of here. We've had a great time. It's been a lot of fun, and I'd like to do this on the moon with Brent.
Of course. How are you, Brent?
How you doing, Johnny?
Good. Very good, very good. So the questions that are running through our head, I mean, what's it like being in here for 14 days?
My first adjective would be it's a lot of fun. It's an amazing vehicle in terms of its operational capabilities. We've done things that you couldn't possibly do with any other class of rover. It's actually comfortable, even luxurious in some regards with respect to the sleep stations and the food prep and all that. It's really been a delightful experience. And like I said, it's bittersweet. I could do another couple weeks.
Better you than me, bro. I don't know if I could handle it. But seriously, I mean, like, is there a bathroom in there? I mean, what do you do? I mean, to pass the time, do you have video games? I mean,
well, one of the things that makes this work so well is that we're busy all day long. We're focused. We're doing geology. We're doing operational things. At the end of the day, we've got some housekeeping to do. Every day, we have exercise for at least an hour. By the time we get done with that, several nights where we watch movies together. We also have a bunch of human factor performance tests to do. So we're basically going at a pretty good pace from about 5:30 in the morning till maybe 10:30 or 11 at night.
so have things worked out the way you expected them to work out?
They really did. I had an image in my mind of what this is going to be like, and it basically was everything that I thought it would be, possibly easier and more fun than I might have expected.
So some of the formation out here, I mean, would you expect some of this on the moon? Would it be kind of similar or the same?
Some of it, studying with the Black Point lava flow itself. It's a basaltic lava flow. On the moon, all the dark spots, all the lunar mare, that is composed of basaltic lava. The top part here is what we're looking at, is very similar to the stuff you would find on the moon. I've had a great time. The science team has been wonderful. Made some really great traverses. For me, this is a dream come true. Doing geology on the moon is actually what got me into geology. So this has been just a really dream come true right here.
So how close is this LER mock-up? I mean, how close is it to being the real thing to you?
Great question. We designed this vehicle as a 1G proof of concept vehicle. Operated within all the functional requirements we have for the flight vehicle. We didn't want to spend the money to make it a pressure vessel and things like that. With respect to our daily operations, it is nearly identical to what the flight unit would be. But we're taking all the lessons we've learned, and I've got 10 pages of notes, but we're going to do Generation 2 starting in October. That will be a ground-up, new design, integrated with the new chassis. With Generation 2, will probably look a little bit more like the flight vehicle than this.
Guys, thank you so much for everything, and we look forward to seeing you guys when you pop out in about a couple minutes or so, all right?
Okay, thanks. Thanks, Johnny.
Most definitely. Thank you, guys.
About an hour after Johnny spoke with Mike Gernhardt and Brent Gary, the LER team pulled into the tent for the last time, completing their successful 14-day mission. After a few minutes of cleaning out the vehicle, Johnny hopped inside the LER with astronaut Mike Gernhardt for a tour.
Can you tell us about the LER program?
Yeah, so the LER program was a concept we came up with not more than 2.5, 3 years ago, and we went from concept and we wanted to evaluate that concept. So we built a 1G concept vehicle that we operate exactly like we would on the moon. So the size of it's the same, the systems are the same, the suit ports on the back where we jump into suits and get on the surface in 10 minutes, all of that's the same as it would be on the moon.
Right.
And the idea was to build it and then take it out and do a real lunar simulated mission to see if it met our vision of what it was.
Right.
And it did. I mean, it actually met it and exceeded it, and then we've learned some minor little things that we want to tweak. But through all of that, by the time we get to the moon, we're going to be hitting the ground running.
Can you tell me a little bit about what we have here?
Yeah, so this is the front cockpit, and we've got great windows. That's the first thing.
Okay.
We can see out these windows, and if you can see down here, there's a helmet bubble. You can put your head in,
I was going to ask you about that.
and I can drive you up within an inch of a rock, any rock you want. So the idea is that we can make observations from inside the vehicle as good or better than we can in a spacesuit.
Huh.
So we don't have to spend all the time in the suits. And when we're sitting inside, we've got cup holders. Here's my coffee.
Yeah, right.
And I can talk to the geology crewmate that I had, Brent Gary, and we can discuss what we're seeing and what our plan is when we go out in the suits.
Right.
All of that makes you much more productive for the time that you're in the suits on the surface.
I see. So, getting into the suits.
Yes.
It's been a big question of mine. I know that you have these ports, correct?
Yes.
Yeah. Can you talk about
Yeah,
that?
and let me give you some background. It takes us at least 6 hours to get out of the space station because we got suits and parts. We got to put the suits together, put them on. We have to do some depressurization things of that nature. So it's 6 hours to get out the door.
Right.
With these suit ports, you can see them in the back. We open a hatch on the inside.
Yeah.
The suit has a back hatch, which we also open, and then we literally step into the suits. Just step into them. And we have a computer display outside the vehicle, and we hit buttons that then close the hatch. And there's a small vestibule between the suit hatch and the interior hatch.
Right.
And so instead of having to depressurize a large airlock with 2 people in it, all we do is depressurize that small vestibule between the 2 hatches. So we can depressurize in like 2 minutes.
Oh, wow.
And not lose much gas.
Right.
Here we can get out the door, boots on the
In
moon
minutes.
in 10 minutes.
Get out, really?
Yeah, and that's a game changer.
Help me compare this to like the old rovers of yesteryear.
Yeah, so big difference. The Apollo rovers were unpressurized, so it's like a little doom buggy or something.
Right.
So you're in there on the spacesuit. You only have 8 hours of life support in your spacesuit. So you have to drive that rover out, do your science,
Right.
turn around and get home before 8 hours runs out.
Oh, yeah.
Okay. In this rover, we have a pressurized cabin, and we can do 2 weeks in here. So instead of having to come home every night, you keep going. So
Yeah.
we can do traverse distances of up to 200 plus kilometers in 2 weeks versus
Wow.
Apollo could never go more than 10 kilometers away from the station.
Sure.
And so we're actually living in these, and that's another big difference. And the other huge thing is that we work with a system of 2 rovers. There's 2 astronauts in each of 2 rovers.
Right.
So as we go out, if one gets stuck or breaks down, we could all 4 get in the other one and come home.
There you are.
And we did that yesterday. We simulated a rescue.
Oh, I know.
And we rescued the crew, and we got back in 24 hours, and it was a fun learning experience.
It's a good mission.
Yeah.
So the LER, I mean, how is this powered?
So this is the Lunar Electric Rover, and it is powered on lithium-ion batteries. And we're really pushing the state of the art with respect to the energy density or the specific energy, the storage of the batteries. So the point is, for us to be successful, we're going to push the state of the art, and our success lines up with the success of electric cars here on Earth. The other thing I'd say, and this is hard to believe, but this whole vehicle, which weighs about 4 tons, it only has 20 horsepower.
How?
But the Humvees can't keep up with this. We can go up 30-degree slopes over big rocks, and it's because we're really smart with the suspension, which is both active and passive, and the traction control system. So it constantly adjusts the forces on the wheels, and it puts all that energy and that power onto the ground. And so all of this really helps the whole green energy, the evolution of where we're going, with the green energy and plug-in cars here on Earth.
Mike, listen, it was great talking to you, and congratulations on a successful mission.
Yeah, well, great, Johnny. It was a great mission. We learned a ton, and it's great to have you guys in the vehicle and see what we experienced for 14 days.
Got it, man. Thank you so much,
thanks
bro.
to 360.
Yeah,
All
you
right.
got it, man. Thanks.
For Johnny Alonso, I'm Jennifer Pulley. See you next time on NASA 360.